Okay, so next speaker is Vinay from Aspiring Minds. I heard a bit about Aspiring Minds yesterday in the Big Data Symposium, and it sounded like some very interesting work around metrics for students and colleges. So I'm very interested in this talk.
Thank you.
Over to you.
Thanks, Varun. A very good afternoon. Am I audible now? All right. So very good afternoon to everyone. Thanks for being in the audience. I am Vinay. I work as a senior research engineer at Aspiring Minds, and I'm here to present our work on spoken English evaluation and automatic grading, semi-automatic grading. So before I go into the technical details, would probably want to explain the problem statement and the motivation behind why we wanted to solve this problem. Spoken English evaluation is a very important problem. According to Harvard Business Review, peers who can speak English fluently earn anywhere between 30 to 50% more than peers who do not speak English fluently. So English, apart from being the lingua franca of the world, also has a very, very deep social and economic impact. What this directly means is that companies would want to know who can speak English fluently. An individual would want to know where he stands in the spectrum and whether he can speak English fluently or not. And if he does not, then what can he do to improve? So student needs feedback. And for training companies, likewise, they also need information on who can speak English where and whether their training is improving the English or not. So there's a huge demand for spoken English evaluation. Now let me get the context right. Just a quick 101 of assessments. Whenever you do assessments, there are two ways that you can do it. Either it can be a constructed response or an open response. Open response is where there is no hints given to a candidate and it's just given an open problem. Let us say I give you a problem of why don't you speak on the flood that you've recently seen. As opposed to I give you a sentence and I ask you to repeat it. While the latter would check the pronunciation fluency, the spontaneous speech or the open response would also check for sentence construction, would check for grammar, would check for vocabulary. So that's a more holistic approach and would give you a more holistic score of whether the person can speak English properly or not. So the problem statement is to be able to scalably grade spontaneous English speech, and the catch here is that we would want to do it as good as experts. So why are we proposing a new method of doing this? For that, let us try to understand what are the present automated ways of doing this evaluation and why are they not accurate. So if you just go through this system flow, what actually happens is that candidates' audio samples are recorded. They go into a speech recognition engine which understands or which transcribes what the person has spoken. If I know what the person has spoken, then I can compare with the global standard and see how well he has spoken. So the whole pivot here remains that I need to understand how well what the person has spoken. The problem here, and I'll probably just emphasize what the problem is, and there's a few technical terms, that speaker independent speech recognition for spontaneous speech is a hard problem. And these terms are important because that is where the assessment angle comes. I want it to be speaker independent. I want it to be for spontaneous speech, which is a hard problem. So now what happens is I do not know what the person has spoken. If I do not know what a person has spoken, then whatever features that I derive from this speech are not accurate enough. If my features that derive from this are not accurate enough, the machine learning models will not do a good job, and hence the final accuracy is pretty bad. For all automated methods, the correlation with the expert grades is around 0.5, which is not good to be used in a high-stake assessment. And when I say a high-stake assessment is when the score that I give will decide whether a person gets a job or not. So it's not accurate enough. So what can we do? We've realized that speech recognition or speech transcription is the rate determining step. So what we did was we removed this aspect and we replaced it with the best known speech recognition engine that is known to us. We replaced it by the human ear. So what we did was we crowdsourced the speech recognition aspect of it. We record the audio samples similarly. we take the speech sample, give it to the crowd. The crowd transcribes it pretty accurately. Human accuracy of speech transcription is around 95%, in some cases more than that. We then get back to the same flow. The speech sample is then forced align onto the speech or the audio files. We generate some features, which I'll explain in the next slide, what features we generate. But because my speech transcription is now accurate, the features that come out of it are also very accurate. Additionally, crowd also helps us give us their own grades. Because a person is grading and he spends some time transcribing it, he also has an estimate of how well the person has spoken. So they also additionally tell us what is their estimate of the speech sample. When we push all this into the machine learning model, these rich features give a very, very huge jump to the accuracy of the final model, and we'll probably go into the details next. We use 3 classes of features. The first one is force alignment features. So as I explained, now that we have the accurate transcription, we have the audio file, we force align the audio file onto the speech transcription, and we generate a alignment file. From there we take out standard features like rate of speech, position, length of pauses, log likelihood, posterior. These all features can be calculated very accurately if we know what the person has spoken. The next is the natural language processing features. Now that we have this text of what the person has spoken, I can then calculate some surface level features like the number of words, the complexity, and also I can look at other semantic features like the coherency of the text, the context of the word spoken, and etc. I can also look for grammar correctness. The third set of features, as the crowd also gives us scores on pronunciation fluency of the candidate, is the third set of features. This is actually, I want to spend some time on explaining what the crowdsourcing task was. We had a few key learnings from the crowdsourcing task that the interface provided to the candidate has to be to the worker has to be very neat and clean. The second learning from this is that the instructions should be pretty clear. Once we are done with this, then so here is the area where the worker transcribes. This is the audio sample that he listens to. This is where he transcribes what he has heard, and here he provides the rating on the different parameters. So pretty simple. The simple learnings from here is that the instructions should be very clear. You should give enough examples to the crowd, and you need to keep the interface neat and clean. One small aspect that we would want to touch when we do crowdsourcing, and why we're emphasizing on this, is again, this is a high stake environment, and whatever we do affects the candidate's final score. We need to make sure that the worker quality is very high. So what we did, we modeled the worker in a novel way. We assigned a risk level to each worker which was dependent on his past work. So higher the accuracy of the previous work of the workers, then lower is his risk level. Based on the state at which he is, we give him a gold standard task to check whether the worker's quality is up to the mark or not. So simply put, I have a prior of the worker. Based on the prior, I will check whether this person is doing the work accurately or not, and I carry on. Before we go into the final task of how we did this, just a quick recap of what we did. With the speech recognition, we removed the speech recognition part of it, gave it to the crowd transcribes it. Now we get an accurate transcription, which we push back into the previous system. We calculate 3 features, which are the force aligned features, the crowd grades, and the NLP features. We push them all into a machine learning framework, and we predict the expert score. We did a supervised learning for this, and to explain the setup, we did this experiment on a sample size of 566 candidates. 319 of them were from India and 247 were from Philippines. These are college students who are applying for their job in the final year of their college. We got 2 experts to grade them. Each expert graded them on an overall score based on pronunciation, fluency, content organization, and grammar. We had an intercorrelation between the experts of around 0.8. The learning task was we modeled the Indian and the Philippine sets separately. We did try to model them together, but the results were not accurate enough, and which we think is because the two sets are very different. The ratings there would be some difference in the two ratings. We would probably have to normalize, which we did not. We tried it on ridge regression, neural networks, and SVMs with cross-validation. For simplicity and to explain the results, I'll just show the ridge regression results, which were the best. So comparing a pure ML approach, and pure ML approach is where the speech recognition engine itself transcribes it. So we see that we get a correlation of around 0.48 in the validation set in the Indian sample, around 0.54 in the Philippine sample, and this is consistent with the previously reported results. And these are clearly inadequate for an high-stake assessment. The second set of results which are interesting is that crowd grades and the MLCS approach. The MLCS approach is where we replace the transcription with the crowdsourced accurate transcription. There's a significant increase. So from 0.48, we jump up to 0.7, and that's a huge jump. And additionally, we also see that crowd grades, if we just use the crowd grades to make the model, they also perform pretty well. So now we have two sets of model which are outperforming the present automated method. So naturally, we combined both of them, and the method outperformed all other previously known methods. We get, in case of the Philippine sample, we get an inter-expert agreement, correlation which almost rivals or nears the inter-rater agreement, which was the aim of the experiment. We also went on to do a case study on the same algorithm, and the idea was to deploy it into a real world situation and see what comes out. So we studied the deployment of the proposed algorithm in Philippines. The event had 500 applicants in the role of a customer support executive. Scoring was done on a subset of 150 students. What we show here is the type 1 and the type 2 error, the trade-off between them. Quickly, type 1 error is the percentage of bad hires which get into the final selected pool, and type 2 is the percentage of good candidates or good hires who get rejected as a percentage rejected to the total good candidates. And we look at the trade-off curve by sweeping over the cutoffs on the total score, and what we see is the red and the blue lines are the existing methods based on an automated approach, whereas the black line is the spontaneous speech score, and it completely dominates the previous existing methods on the whole range, which was pretty encouraging. So what are the contributions? So the first contribution is that we propose a semi-automated method to do a scalable, spontaneous English evaluation with accuracy nearing inter-expert agreement. And the second contribution is something that we would want to talk about a little more. So here what we propose is the crowd helping in feature generation. As opposed to other previous methods where the crowd would be directly doing assessments, what we propose is an architecture where we would break the whole task into smaller subtasks, which are human intelligence, and the crowd works on them, giving us features which are much richer than the automated methods, which help increase the machine learning model. So the crowd input here is directed at the feature engineering step rather than giving assessments or giving the final score. Thank you. And I would probably want to leave with who we are. So we conduct standardized employability test and assessment based for employability. The flagship product is called AMCAT, and we are the GRE/SAT for jobs. We conduct 1 million tests per year. 2,000 plus companies use AMCAT for hiring. 400 companies post around 800 jobs on our website. So with all this data, what we envision is a labor market which is driven by merit, where talent and opportunity have a fair game. And we use this to also improve the existing product, make new products, all this data, and also to unearth the biases and to have and map the whole labor market. Thank you, and I'm open for questions.
Thanks, Vinay.
Yep.
So, any questions? All right. So,
I think there's one.
oh, thanks.
There's one.
Thanks for the presentation.
Yeah.
I have two questions. The first one is about you said about existing methods. So, which are existing methods? Can you explain?
So there are two sets of methods. If you want the small technicality, the existing methods are either on read speech, where the candidate would be given some text to read, and that now that I know what has been spoken, I ask them to speak. The other is a pure automated method where the speech recognition engine transcribes the text itself. So those are the two existing methods.
Okay. So another question is about like spoken English. So it's a bit different than the written English.
Sure.
Because spoken English can be different from region to region. For example, British spoken English is different from Americans. Within Americans, you have Texas a different pronunciation. In others are different. So which you are focusing on?
So when you talk about spoken English as a generic term, then I agree with your definition that each region has a separate definition to it. But when you talk about spoken English for a job in a global context, then we all probably converge to a standard definitions that saying that the accent should be neutral. You should be using you conversing in words which are probably common to each other. So once we specify the context clearly that we are saying spoken English for employment, then the definition becomes much tighter.
That which one are your?
It's a neutral accent. That's the standard. So I want to evaluate a neutral accent used for employment in a global context.
Okay, thanks.
There's a question in the back there, if we have time.
I was just wondering, while you're talking about that there's a neutral accent and a commonality, I was wondering if you're actually taking any of the content at all with the language that might come into a CV or an application or their history to develop any archetypes at all. So then, because you'll find that there is specific jargon to a medical or to a legal profession that isn't in a teaching or a social science profession, for instance.
Sure.
So are you actually doing anything about cross-indexing the data that you've got and mining it to develop these archetypes to then build more relative baselines to the applicants and job types in the future?
Sure. So how do we tackle that problem is that we have an architecture where we separate the spoken English part to the domain where the language works. So each domain would have a separate application. So for a person who is speaking in a business line, there would be a separate skill of how he understands conversations and how he handles them. What kind of language would he, kind of terminology would be interacting with. So that is a separate skill, or let us say a separate dimension, as opposed to his spoken English skill. So the complete product that we offer, and that's called SWAR, has both components. So one component would be at the spoken English evaluation, spoken English aspect, regardless of which profession he is, and there's an outer layer which would then wrap it around for different professions, and when you merge both of them, then you get a domain-specific score.
Have you given any thought to what happens to people like me that have had several careers in totally different areas? So, for instance, at one stage I've been a chef, I've been a data scientist, I've been a radio DJ, I've been a storeman and packer. So in that sense, I've got multiple backgrounds,
Sure.
and I'm sure that would sometimes put noise in your models.
Glad to know that. That's a varied profession, and that might be inspiring for me. But what actually defines is where you want to go finally. So the next immediate job that you would be applying for is where we will be evaluating you regardless of what your previous history is. Your previous history might get something else, but you need to first clear the basic cut for the next job. So when we are saying that what is a benchmark for the next job, it's an immediate thing, though the other things will always be there. So.
Okay, thank you.
Thanks. There's one more question.
There's another one?
Yeah.
Thanks. Hi.
Hi.
Walter Lasecki, University of Michigan. So, very nice presentation. I was just wondering, you use inter-rater reliability, essentially, or inter-annotator agreement as a measure. But I'm wondering what the actual comparison between the crowd and the expert was in terms of the value, the rating that they actually gave.
So you're saying what is the correlation between the crowd grades and the expert grades?
Yeah.
They would be around, so this would be probably it, right? So 0.67. So it would be, because this would be regressed over all the 4 crowd grades, so it would be around, individually it would be around 0.6 and less than that.
Do you have a sense of how it actually compares? Is the crowd more generous, or?
The problem with crowd is that there is something called rater drift, and there's a rater bias, because each person would not be rating all of the candidates, and so it's not easy for me to compare specifically saying that whether the crowd is more generous or less generous. All I can say, it's not as accurate as experts, because it's not an easy comparison for me to make.
Right. And there are some ranking methods that actually take into account how to adjust
Sure,
that.
exactly. So you can then go into that field of study of how to merge all the crowd gradings in a better manner, which we haven't gone into. We right now take a simple average.
Yep. Cool. Thanks.
Yeah.
Thank you. Any other questions? Oh, so I'll just ask one little question. Thanks.
Yeah.
So you mentioned, this whole thing goes to making quite an important decision for applicants. And so I don't want to impugn the business model for your company, but is there any danger of irate, false negative employees sort of complaining or suing or doing anything like that?
So we don't make the final decision of saying whether the person is hireable or trainable, or hireable or not hireable. What we say is that we'll probably get to a much smaller set of people from where you can hire much better. Whereas the human aspect always remains, because there is a company characteristic attached to every company, which probably I cannot model right now into the machine learning algorithm. So what we go to the companies and say that here is a much smaller subset instead of you. So how we solve that problem, interestingly, is there's 2 sets to it. The companies don't go to students anymore. We go to the students and get the set, and then we give them a smaller subset. Instead of them going over 1,000 candidates, we said, hey, you get here, you have 100 candidates, and you'll probably select 90 of them. So I am at never any stage not making the decision saying that he's hireable or not hireable. It's always a potential smaller set where you will get better candidates.
Okay, thank you. All right, so let's once again thanks Vinay for his talk.
Thank you.